So let's go over the part 1 worksheet for chapter 2. First of all, let's talk about scientific notation. So in problem 1, you have to write the following in standard notation. Wanted to remind you a couple things. When the power of 10 is negative, we're looking at a small number, meaning that your number will be less than 1, and we will move the decimal point to the left. When your power of 10 is positive, we're looking at a big number, therefore, number greater than 1, and we will move the decimal point to the right. Let's take a look at the first problem. So 2.3 times 10 to the negative 3. The answer will be 0.0023. I have two sig figs here, so I have the two sig figs right there. Remember that the leading zero do not count as sig figs. 5.19 times 10 to the third. So when I convert this to standard notation, I'm going to move 3 times the decimal point to the right, and I get 5190. Now, what you can ask yourself is, do I have the correct number of sig figs? And I see 3 sig figs here, 3 sig figs here. The 0 that you have right here is called ambiguous and does not count as sig fig. Okay. C, 1.54 10 to the negative 1. We're going to move 1 time the decimal point to the left. 0.154. I have 3 sig figs here, still have my 3 sig figs right there. Problem number 2. Write the following in scientific notation. So this time we're going to do the opposite. So when we look at the first problem, we have a big number. We expect a positive power of 10. 1.3 times 10 to the 6. Why 6? Because your decimal point is right there, and you will need to move your points 1, 2, 3, 4, 5, 6. Remember that the coefficient needs to be greater than 1 and less than 10. What do we call the coefficient? This part here. Oops, sorry. This part here is what we call the coefficient. 0.053. So it's a small number, so we expect a negative power of 10, and we're moving the decimal points to the right 3 times, therefore 5.3 10 to the negative 3. C, so why C has to be converted into scientific notation? It's because the coefficient here, it's not a coefficient, okay? Remember that your coefficient needs to be greater than 1 or equal to 1, but less than 10. And this is not the case right there. This number is less than 1. Therefore, we're going to convert this number into scientific notation. And this number in scientific notation will be 8.56 times 10 to the 4th. So how do I do this? There's two options, but the easier one will be to convert the green part into scientific notation. So this is 8.56 times 10 to the negative 3. Then I will time this by the 10 to the 7, and adding these two give me the 10 to the 4th. Okay, 10 to the negative 3 times 10 to the 7th is 10 to the negative 3 plus 7, 10 to the 4th. Remember your rule for the exponents? So what are they? 10 to the power A times 10 to the power B is 10 to the power A plus B. 10 to the power a to the power b is 10 to the power a times b. 10 to the power a over 10 to the power b is 10 to the power a minus b. This is what I used right there, okay? Here, I used the 10 to the a times 10 to the b equal 10 to the a plus b. 3, without using a calculator, can you solve these and then check your answer with your calculator? So when you type this on a calculator, just wanted to reinforce that you have to input parentheses underneath, okay? Therefore, we have here the coefficients. If we do this by head, 9 over 3 is 3. Then we can take care of the exponent right there. This is going to be 10 to the 8 over 10 to the third. This is 10 to the 8 minus 3. This is 10 to the 5. Therefore, the answer is 3 times 10 to the 5. And you can check this on your calculator. 2 times 10 to the 4th to the 2nd. So how do we do this? We're going to first do first part. This is 2 to the 2nd. You distribute the power of 2. This is 4. Then we can take care of the power here. And we have right there 10 to the 4th to the 2nd. So it's 10 4 times 2. Therefore, 10 to the 8th. Let's put this together. And we get 4 times 10 to the 8th. You can check this on your calculator. The last one here, so what are we doing? We're going to grab the 4, the 4.5, and the 9. 4 times 4.5 is 18, so we end up with 18 over 9, okay? 18 over 9 is 2. And if we do the power of 10, then we end up with 10 to the 4th times 10 to the negative 3 over 10 to the negative 5. This part here is 10 to the 4th plus minus 3. So it's 10 to the 1. 10 to the 1 over 10 to the negative 5. In order to do this, what will I do? Then it's going to be equal 10 to the 1 minus 5 equal 10 to the 6. Therefore, my answer, and you can check with your calculator, will be 2 times 10 to the 6. Okay, so when you type this on your calculator again, be sure that once you put the division, the 9 times 10 to the negative 5 is underneath. Okay, this is a very common mistake. Learn how to use your calculator. Very, very important. Let's talk about unit conversions now, okay? And we're going to take a look at first how many you can do without looking them up, without looking at the answer, okay? In problem 4, you need to circle the larger units. And as you can see, how units are built, they're built with a prefix and a base unit, okay? And the prefix actually give you the size of the base unit. You have prefixes that make them bigger, and you have prefixes that make them smaller in comparison to the base unit. Kilometer and centimeter. So what's going to be the biggest one? Kilo actually will be the biggest one because kilo is 10 to the third. On the other hand, centi, 10 to the negative 2, and 10 to the third is bigger than 10 to the negative 2. Problem B, what do we have here? Milligram and octogram. Well, octogram is going to be the bigger unit because octo is 10 to the second, milli is 10 to the negative 3, milli is smaller than octo. C, nanosecond and picosecond. Nanosecond will actually be the bigger unit because nano is 10 to the negative 9, pico is 10 to the negative 12, therefore 10 to the negative 9 is bigger than 10 to the negative 12. And then finally, microliter and deciliter. Well, deciliter will be the bigger unit because deci is 10 to the negative 1, while micro is 10 to the negative 6, and 10 to the negative 1 is greater than 10 to the negative 6. How do we build those conversion? Well, actually, it's very simple. The value of the prefix can be replaced by its meaning. Okay, so micro is 10 to the negative 6, milli is 10 to the negative 3, kilo is 10 to the third. The only struggle you might have here is what about this one, B? Okay, because if you look at B, the prefix is on the other side. So my advice when you end up with this is to go back to the root, to go back to something you know. 1 microgram equal how many grams? And we're going to do the same thing we've done before. We're going to translate micro. And micro is 10 to the negative 6. Therefore, I need to switch, okay? And I need to know how many microgram there is in a gram. Therefore, it's going to be the opposite, and here is going to be 10 to the power of 6 because I have a lot of microgram in 1 gram. Significant figures, also known as significant digits. Find the number of significant figures in each measurement. You will have to apply the rule of sig figs. For A, there's 3 significant figures because the 0 being in the decimal portion will count. B, you only have here 2 significant figures, the 5 and the 2. Remember that the leading zeros do not count as sig figs. They're only here to give you a size for the number. This number, so here I have 2 sig figs. An easier way to remember this is when you convert this number into scientific notation, then you will see that your coefficient has exactly the same number of sig figs. Okay? 0.308 kilojoule, 3 sig figs for that one. The 0 in the decimal portion located in 2 non-zero digit counts, so I have here 3 sig figs. And finally, the beauty of scientific notation, all the digits in the coefficient portion of scientific notation are always significant. This number has 5 sig figs. The zeros are located in the decimal portion, so they will always count. And be careful here, if you were to convert this number into standard notation by moving 3 times the decimal to the right to make it a big number, this will be 8902.0 meter. Reason why, it's because once you go back and forth between scientific notation and standard notation, you need to keep the same number of sig figs. Problem 7, in this chapter, you'll learn about quantities that are called exact numbers. So what are exact numbers? These numbers can be counted and they have an unlimited number of sig figs, okay? Infinite, unlimited number of sig figs. Therefore, 0.50 pounds, this is not an exact number because this is measured, not counted but measured with a scale. Therefore, this number has 2 sig figs. 17 eggs, it's obvious that I can actually count this. Therefore, I have here something that can be counted. If it's being counted, this is what we call an exact number. And because it's exact, it will have an infinite number of sig figs. $300K, this is a temperature. K stands for Kelvin. You have to measure this temperature. And these 2 zeros that you see on the right side are called ambiguous zero. Therefore, they're not significant. And I see here that I have 1 sig fig. 3/4 of a mile, fractions as well as counted number are exact numbers. So this number being a fraction is an exact number, and if this number is an exact number, it will have as well an infinite number of sig figs. Let's go on the back side of the paper now, where we need to round numbers. So you'll remember in rounding, you're gonna have to look at the digits you wanna drop. If this digit that you wanna drop is greater than 5, then you will round up. If your number that you wanna drop is equal to 5 or lower, if your number is lower than 5, then you will round down, okay? If your number to drop is 5, you will actually round up. So let's take a look at this. For the first number, we want 4 sig figs going from the left to right. This is the 4 sig figs I will keep. Therefore, I want to drop this number. I want to drop 6. If I drop 6, I need to round up. And to 4 sig figs, this number is 1.238. For number B, I want to round to 3 sig figs. Remember that the 0 up front doesn't count, so those are my 3 sig figs. Therefore, I want to drop a 5. When I drop a 5, I round up. Therefore, my answer to 3 sig figs will be 0.776. Problem C. I need 2 sig figs here, 114.1. So I just want to keep these 2 digits right there. And I'm going to drop a 4. Therefore, if I drop a 4, we do what we call round down. Therefore, we do not touch anything. I'm going to keep the 2 ones, but what you have to be very careful of is usually students tell me, well, this is 11. You need to keep the size of a number. Therefore, the number that you're dropping that is being part of the non-decimal portion has to be kept. Why do you need to keep the 0? To keep the size of the number, okay? So you add a 0 here because you want to keep the size for the number. Another way to visualize this is actually to go to scientific notation. This number is 1.41. Sorry. This number in scientific notation is 1.141 times 10 to the second. If I want to keep 2 sig figs here, it's obvious that this number is equal to 1.1 times 10 to the second. Well, 1.1 times 10 to the second in standard notation is 110 and not 11. Record the measurements shown on the following instruments. Express your answer using the proper number of significant figures. So let's take a look at the first one. It's a ruler, and the mark on this ruler is shown with the little arrow. Let's analyze the instrument first. What you have to do first is really to analyze the instruments and analyze the mark. So what kind, let me just have it smaller here, the marks. So here, it's 12. Here, it's 13. So what are this little teeny tiny mark in between? Well, you see that you have, it's subdivided in tenths. Therefore, this one will be 12.1. And it's still big, but it's okay. And then the next one will be 12.2, 12.3, and so forth. The arrow is located here. Therefore, this arrow is in between this mark and that mark. The mark on the left stands for the 12.3, the mark on the right for the 12.4, obviously centimeter. Therefore, I am 100% sure that the red arrow is greater than 12.3 and smaller than 12.4 centimeter. And I am 100% sure of these 3 digits here, okay? So those are called my certain digits. 12.3. When you report a measurement, we need three things. We need the certain digits. What else do we need? We need the estimated digit. The estimated digit depend on the person doing the measurement. And here it looks like this red arrow is right in between 12.3 and 12.4. So I could estimate this digit as being 5. But if you wrote 12.34, you're correct as well. If you wrote 12.36, you're correct as well. You just did a different estimation that I did. Okay, so really wanted to emphasize this. The estimation is on the end of the experimenter. Okay, so 3 parts for the measurement. In green, the certain digits. In pink here, the estimated digit. And do not forget the unit. Those are the 3 parts for every measurement. Let's take a look at B now. So we already have the unit, milliliter. We look at this instrument. It's a graduated cylinder. What you have here, it's called the meniscus. Okay? Therefore, we're going to observe and measure here. And I should have done something so we can actually see the line. So let's have the meniscus highlighted here so you can still see the line underneath. Okay, so let's analyze the instrument first. When I analyze this instrument, I see that this is 25, so here 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. My meniscus looks like it's on the 30 line, okay? And I am sure of the 0, okay? I'm right on the line. Again, if I look at this carefully, that's 26, that's 27, that's 28, that's 29, that's 30, 31, 32, and so forth. So when I look at this instrument, I'm sure of the 2 digits. I'm sure of the digit that comes just before the decimal point, okay? Therefore, the 30, I see the 30 will be counted as my certain digits. So the 0, the 0 here, I see the 0. To express the fact that I see the 0, I'm going to be putting a point here, okay? So the 30 points represent my certain digits. I've seen the 0. That's why I put the 0 and the point. But remember that every single measurement comes with 3 digits. Therefore, I'm going to need to add my estimated digit, my guesstimate. And here, it looks like it's right on the line, so I'm going to add the 0 as being my estimated digit to complete my measurements. If you decided to make this a 0.1, that would be completely okay. If you think that it's slightly above the 30 line, that's okay, and you will get full credit, and we'll be okay with that. So we do have 3 part of the measurement. We have our certain digit, the 30. We have our estimated digit, the 0, the 0.0, I mean the 0 after the point, and then the unit that is the milliliter. Let's take a look at the next instrument. Here, the unit is in degree Celsius, so it's a thermometer. And let's take a look at the marking because we always need to study the mark first. Observe that this goes every 1 degree Celsius, so that's 20, 21, 22, and so forth. Therefore, the level in the thermometer is in between 28 and 29. Again, if we look at the level here, okay, this is right in between. So it's greater than 28 and less than 29. And for this reason, I am sure of the 28th. So the 28th will represent my certain digits. I'm going to write it down. Don't forget, I'd always need an estimated digit, and it looks like it's right in between, so I will estimate this as 0.5. If you estimate this as 0.6 or 0.4, you're still okay, and you still have the correct answer, okay? So this one is my estimated digit. We have the three part of the measurement, the certain digits, the 28, the estimated digit, the 5, and it's always only one estimated digit. You cannot go over one. It's only one digit that you can estimate. And then the units. So we recorded the proper measurements here. Let's keep going now. For problem 10, you need to complete the following calculations, and you have to answer to the correct number of significant figures. For that one, you need to apply the rule of calculation for significant figures. For addition and subtraction, we go by number of decimal places, and the answer will be given to the least amount of decimal places. So let's take a look at this. A, 42.3, one decimal place, sorry. 12.129, three decimal place. 3.22, two decimal place. So let's write it down. Here I have one decimal place, here I have three decimal place, and here I have two decimal place. The rule goes with the least number of decimal place. So what we're gonna do first is type this on our calculator. When you type this, the calculator gives you 57.649 centimeter. Do not centimeter, don't forget your units. Again, this number comes just from the calculator. We're going to apply the rule of addition that goes with the least amount of decimal places. One decimal places is the least number of decimal places. So this is what I'm going to keep for the answer. We will only keep one decimal place. Therefore, we are dropping a 4 and we're going to round down. And our answer will be 57.6 centimeter to the correct number of sig figs. For B, it's a multiplication. The rule for multiplication and division is different. It goes with the least number of sig figs. So let's take a look at here, and we're going to do sig figs. The first number, 15.3, has 3 sig figs, all non-zero digit. The second one has 5 sig figs. The 0 and the decimal portion do count. When we do the multiplication, we're going to first use our calculator to find the answer without rounding yet. So we have 185.589. Do not forget your unit. Meter times meter, give me meter square meter. And now I apply the rule of sig figs. I'm going to keep the least number of sig figs in my answer. Therefore, I need to only keep 3 sig figs. And here, I'm going to keep the 1, the 8, and the 5. Those are the 3 sig figs that I will keep. Therefore, I need to drop a 5, and I'm going to round up. And the answer to the correct number of sig figs will be 186 square meter. Now, what happens if we mix everything? If we mix multiplication, division, subtraction, and addition? Well, you're going to have to perform those calculations step by step. Remember that the PEMDAS, okay? So remember the rules, PEMDAS, parenthesis, first, okay? And then exponent, multiplication, division, addition, and finally subtraction. So we see that we're going to do first the parenthesis right there. It's a multiplication. We have 2 sig figs here, and we have 5 sig figs here. We're going to do this on the calculator. So on the calculator, we're going to do 3.1 times 2.4367. And the calculator gives me 7.55377. It's a multiplication, so I'm going to go with the least amount of sig figs, and I should only keep 2. But I'm not going to round yet because I'm not done with my calculation. I'm going to bring down this part, minus 2.34, equal, the calculator gives me 5.21377, but this time it's a subtraction, so I'm going to go with decimal places. I have here 2 decimal places, and here, because I should have kept 2 sig figs from the first step, this number per the multiplication rule only has 1 decimal place that is valid. So the subtraction comes for 1 decimal place in the first number minus 2 decimal place in the second number, least amount of sig figs win. So my answer will be given to 1 sig fig, and I will get a final answer as 5.2. I'm dropping a 1, I'm going to round down. And this is the answer to the correct number of sig figs. 81.9 plus 15.6 divided by 4.7. PEMDAS, so parenthesis first. So let's take a look at this here. It's an addition, so we're going to go by decimal places. 1 decimal place, 1 decimal place. Therefore, our answer should be given to 1 decimal place. 81.9 plus 15.6 give me 97.5. And I keep the 1 decimal place. And then I'm going to bring down the divided 4.7. So divided by 4.7 equal, the calculator gives me 20.74468085. But this time it's a division, so I'm going to go with the least number of sig figs. Well, this number here is 3 sig fig, and this one is 2 sig figs. So we have 3 sig figs here, 2 sig figs here. The least amount of sig figs win, so we're going to keep only 2 sig figs. We're dropping a 7, so we're going to round up, and our answer to the correct number of sig fig is 21. I hope this made the first part of chapter 2 more clear for you. And remember that if you have any question, please feel free to reach out, okay? Take care. Bye-bye.